This is the checking layout. The purpose of the checking layout is to perform the quality checks for the model or several models based on selected rule sets. Checking layout consists of the checking view, while results of the rules are shown in the results view. We also have the info window at the bottom and the 3D view on the right-hand side. So to start our check, we'll check the rules that we have here. These rules are for general validation of architectural designs. You can see we start to reflect some results here after hitting the check button. So we now have results in critical, moderate, and low severity levels. Let's take a look at some of the spatial checking as well as the space validation results. So after we've looked at our severity issues, we can go to space checking, for example. Click on space validation. The results of the rules we just ran can be seen here. Let's click one of these, this boundary issue, for example. In the 3D window on the right, you can see that the 3D view is temporarily hiding everything except those elements that are related to this issue. This allows you to see the problem more clearly. Part of the 3-dimension space object is missing as the space is not aligned with the surrounding wall. The area is automatically redlined, and when you compare this with the footprints of the walls, you can clearly see where the problem exists. Normal procedure is to comment on this issue, so we can select the default comment or description that is generated from the rule, and we can continue adding some additional information. So we hit the Set Default button, and now in this comment window we can add additional details. Notice that by default the issues are all rejected, so our decision in the top right of the Result Details window shows the issue is rejected. We'll look at another example such as interference checking. Here we have some overlapping walls. When you double-click the issue, the problematic components are automatically centered and zoomed to in the 3D view. Again, as previously, just the relevant information or components are shown. In this case, you can read from the info view that there are duplicate components. There's one wall component inside the other. In case you need to have an overall view of the level of overlapping components you have, you can have a look at the related report. So in our intersection checking, we have this ruled report icon. We can double click on that. For example, here you can see all the wall types that are used in the model, the total component volume for each, intersection volumes, how much this is by percentage of the whole model or the whole volume. This will indicate, for example, how much your quantity takeoff may be off at the moment. You can also export this directly to Excel to a spreadsheet. Okay. Let's take a look now at how the severity classifications work. If you want to, for instance, focus on high severity problems, we can choose which of the issues we want to view. So in this case we can hide, for instance, normal and low severity issues. So currently we're seeing both high, moderate, and low severity issues. But if we hide those components with moderate or low severity, we're just viewing items with high severity issues. So now you can only see the critical and rejected results, like the wall intersection that we just marked as rejected. This is the most important layout in Solibri Model Checker, since this is where the quality of the model is checked by rules. In this case we have one rule set checked, but you may also add more rule sets from here. So for example, let's select the accessibility analysis rule set. Some of these rule sets have further instructions, and in this case we see that we need to define the classification for spaces. Properly done classification is extremely important for the accessibility analysis, for example.